In today's lesson, I'm going to do a few questions on partial fraction decomposition. So the first example I'm doing is when you have a constant as a numerator and then a quadratic function as a denominator. So what do you mean by partial fraction decomposition? We want to decompose this into two fractions by adding two fractions or subtracting two algebraical fractions. And the benefit of doing this is that when you will start doing when you will be doing the calculus, then if we want to integrate this function, then the first step has to be by decomposing this fraction. So now what do we need to do here is, first thing is that we know the denominator can be factorized. So let's see, x, and this is 1 and 2. This has to be positive, this is negative, so both has to be negative. So which means we already know this is 1 over x minus 1 and x minus 2. So we already know that we can represent this as x minus 2 and x minus 1. So now what we want is to decompose this into two fractions. So 1 over x minus 1, x minus 2. We can rewrite this as, let's say this is equal to, doesn't matter, you can have a over x minus 1 or a over x minus 2 and b over x minus 1. So it doesn't really matter here. So I can do this, or I can do a over x minus 1 plus b over x minus 2. It's the same thing here. So now I'm going to start with, so I'm going to choose this one here. So this is a over x minus 2 plus b over x minus 1. Okay. Now I have to make the denominator same, which means I need to multiply. If I want the denominator same here, so that this, I want the denominator of both left hand side and right hand side to be cancelled out. So which means I have to multiply this by x minus 2 and this by x minus 1. So I will get here, so this is equal to 1 over, no change on the left hand side. This becomes a x minus 1, b x minus 2, divide by x minus 2 into x minus 1. Now this get cancelled, so 1 is equal to a x minus 1 plus b x minus 2. Now I'm going to open it, so a x minus a plus b x minus 2b. So this is equal to 1. I'm going to collect like terms. So a plus b times x. And then I got here negative a minus 2b. So collecting like terms. So this one and this one together. And this one and this one together. Now, after that, to find the values of a and b, we need to compare the coefficients on both sides. So left hand side has no x term, which means 0 is equal to a plus b. So we got one equation from here. And constant term on left hand side is 1. So 1 is equal to negative a, negative 2b. So now from here, I can find a is equal to negative b, or b is equal to negative a. So then I'm going to replace this a by negative b. Since I have negative a, so this becomes b minus 2b. So 1 is equal to negative b. So b is negative 1. And then a will become negative 1. So a is equal to 1 here. So we found both values. A is equal to 1 and b is equal to negative 1. Which means, so here the decomposition of, so the decomposition of 1 over x squared minus 3x plus 2 is equal to a, which is 1. So 1 over x minus 2, b, which is negative 1, x minus 1. So this is the decomposition of 1 over x squared minus 3x plus 2. 1 over x minus 2, negative 1 over x minus 1. Let's do another example here. So the next example is 2x minus 5 divided by x squared plus x minus 2. Now the difference between this example and the previous example is, in previous example your numerator was a constant and here the numerator is a linear factor. So step is same. So first we need to see if we can factorize it. So this is x and x, this is 1 and 2. Now we need plus x, which means has to be negative 1 here. So 2x minus x gives me plus x. So 2x minus 5 x squared plus x minus 2 can be written as x minus 1 and x plus 2. Now again, it doesn't matter which one you assign to a, which factor you want to assign to a, which factor you want to assign to b, it doesn't matter. So I'm going to just choose x minus 2 b over x minus 1. Now again, we need to make the denominators same. So here I need to multiply by, sorry, this is x plus 2. Okay, so I need to multiply by x plus 2. And here I need to multiply by x minus 1. Now after that, you will get 2x minus 5, x minus 1, x plus 2. This is a, x minus 1 plus b, x plus 2, x plus 2, x minus 1. So this get cancelled. 2x minus 5, I'm going to open the brackets in the numerator, minus a plus bx plus 2b. Now collecting like terms here, so this one and this one, this and this. So we got a plus b x minus a plus 2b, and this is 2x minus 5. Now comparing coefficients and constant terms. So here the coefficient of x, so coefficients and constant term. So coefficient of x, left hand side is 2, right hand side is a plus b. So it gives me one equation. And the constant term, so this is coefficient of x. This one is constant term, negative 5 is equal to negative a plus 2b. Now I'm going to replace one of the variable here. You can do that, or you can, in this case, maybe this is much easier. You just need to add them. This is simultaneous equations. You know how to solve it. So if you add it, this is going to be negative 3 is equal to 3b. So b is equal to negative 1. Once you have b is negative 1, so 2 is equal to a minus 1. So 3 is a. So you got a is equal to 3 and b is equal to negative 1, which means our decomposition in this case is, so decomposition in this case is going to be 2x minus 5 over x squared plus x minus 2 is equal to a 3 over x plus 2 and then minus 1 over x minus 1. So that is your decomposition of this one, which consists of two fractions and subtraction in between those two. So that's it for today's lesson. You can check it, actually you can graph it and can see that you can graph this function and then you can graph this one and then you can see that the graph will be same. Or you can again, simplify it by simplifying the right hand side, and then you must get the left hand side here. So that's the way you can again check. So that's it for partial fractions decomposition.